Okay, we are recording, and I've got a backup recording. Okay, great. Let me share my screen again. Okay, thank you everyone for joining us today. It is Thursday, February 13th, 2025, and you are here for the Unleash the Power of Hiero, a developer's guide to our SDKs featuring Hendrik Ebers, who is a member of the Hedera team, a member of the Hiero team. He's also a member of the Technical Advisory Council for Linux Foundation Decentralized Trust, and we cannot be more thankful for him taking the time to put on this workshop. We think this is going to be great. We really appreciate all of you showing up. LD Decentralized Trust, we are the Linux Foundation's flagship organization for the development and deployment of decentralized systems and technologies. As with all Linux Foundation meetings, this is held under the Linux Foundation antitrust policy. If you have any questions about these matters, please contact your company counsel, or if you're a member of the Linux Foundation, feel free to contact Andrew Updegrove of the firm Gesmer Updegrove LLP, which provides legal counsel to the Linux Foundation. The antitrust policy link will be shared in chat in a moment. And as with all Linux Foundation meetings, this is held under our code of conduct. Everyone is welcome here. I have a colleague who likes to say this is best. Our code of conduct can be best summed up as be excellent to each other, and we'll all get along just fine. And lastly, get involved. Open source only works with you and with folks like Hendrik and with everyone on this call getting involved. And we can't thank you enough for being here to learn about Hiero today. But you can sign up for a Linux Foundation account. You can check out the code in the GitHub repositories for Hiero or other projects. Check for bugs or report a new one in the database, but also look on these projects under issues for good first tickets. They're a great way for you to ease into a new project. And Hiero is a new project here, and we're pretty psyched for it. Check out the contribution guides for a project or a lab. Find the meeting info. The Hiero team is meeting. That could be a great way for you to enter this community. And then use our comm channels if you have any questions. I'm going to share a number of those in chat. And with that, I'm going to stop sharing and turn it over to Hendrik. And it's all yours, Hendrik. Good to go.
Perfect. Thank you. Okay, so welcome from me too. Happy to see that many people, and just in this minute, 2 additional people joined. So yeah, happy to have that many people here live in the webinar. So let me just find the right button to start sharing. So as Sean said, I would like to talk about Hiero SDKs and the SDKs of Hiero today. I'm Hendrik. I'm from Germany, and I'm part of the Hiero project since its beginning. I'm leading the TSC on the project, and even before the sources that are defining the Hiero project moved to the Linux Foundation and to LFDT, I was part of the team working on that project, which was then the source code of Hedera, and I'm part of Hashgraph, which is the company that is working on all that, and I'm the director of open source at Hashgraph. And with that role, I try to move this project and other open projects or open source projects forward, since I'm not only part of Hiero and the Linux Foundation Decentralized Trust. Next to that, I'm, for example, a member of the board of the Eclipse Foundation, so trying to get involved in general in the open source ecosystem. But today we would like to concentrate on Hiero, and at Hiero especially concentrate on the SDKs. So I have some content I have prepared for today, which starts with some slide content, and then later we will do some live coding, really look into code, and it will get way more interactive. So that is my idea for today, which means if you are interested in like creating your first small application that is connecting to a decentralized network and doing transactions against that decentralized network, this webinar is exactly for that, because that is what we will try to do here, to create those first small samples, um, and see how the Hiero SDK works, how you can use it, and so on. So, but before we come to that and coming to the more interactive part, I think since Hiero is a quite new project, it makes sense to talk a little bit about Hiero. So, since I would like to do or make this an interactive action anyway, especially when we do some coding, and I hope one or the other people tries it on their own then. Whenever you have a question, whenever you have a content, feel free to write into the chat, feel free to unmute yourself, feel free to start a discussion. So we have some time today to do exactly that. I'm happy to answer questions whenever you have some. I will just directly open the chat, which is now somehow closed because I see there are already new
And
messages.
you just asked about letting folks unmute. I just fixed it. If someone wants to unmute, we would ask to allow Hendrik to run this workshop properly. If you want to ask a question verbally, please use the raise hand function
Yeah, and
under
yeah.
React in Zoom. But Hendrik, we're good to go.
Okay, perfect. Thank you. So, okay, yeah, and I'm just seeing you added a lot of links like to the Hiero website, to starting contribution guide, and all that. That is already awesome. I have some of those links in my presentation too. But so let's start with the content and talk about the Hiero project and what the Hiero project is. So the Hiero project is part of the Linux Foundation Decentralized Trust, which is a sub-foundation of the Linux Foundation, concentrating on DLT technologies. And yeah, since it's part of the Linux Foundation, for sure, it's open source, and it's already heavily used because it's a base of the Hedera network, what several of you might already heard about, I assume. So, since it's a source of the Hedera network, the code already existed before Hiero was started. Because what happened is, or where we still at, is that Hedera is transferring their code base, so the code base on that the Hedera network is running to the Linux Foundation as a vendor-neutral open source project, which is Hiero, with the idea to allow others to use that code to run their own networks, run private networks, run public networks, maybe in universities or something like that. And by doing so, create a code base that is used in multiple projects that might become a standard in future and so on. And with that, I think we did a huge step when talking about having open source and vendor neutral distributed ledger technology, which from my point of view is quite important, especially when it comes to topics like enterprises and things like that. So I don't want, since we want to talk about the SDKs today, don't want to go that deep into Hiero and talk about what are distributed ledger technologies, where should you use them, and so on and so on. So if you want to know more about it, I have two links for you. One is my YouTube playlist, where especially some of the last videos are all related to Hiero and the technologies around Hiero or Hashgraph or Hedera. And next to that, in the GitHub organization of Hiero, which is github.com/Hiero we created a repository that is called Awesome Contributions. And in that repository, we correct like all the articles, all the getting started, or the videos about Hiero, and there you can already find like several good starting points to learn about what is Hiero, where can you use it, and so on and so on. So yeah, if you're interested in that, you can always look at that. And if you do something with Hiero, please ping me or somebody else from the Hiero community, because I would be more than happy to add your work to that repository and highlight you. Um, Okay, so as said, I don't want to go that deep into the topic, but maybe there are some people here who never worked with a distributed ledger, with distributed ledger technology. So I have one sample here, and that sample shows what you can do with those technologies, and it's a real world sample, so a real use case that happens, and I use that use case quite often to describe the benefits of distributed ledger technologies. And this use case is the point where somebody who's living in South Africa would like to transfer money to a person living in South Korea. Okay, so that sounds like a super easy use case, right? Because I mean, you go to your bank, you do a bank transaction, and you're done. So that sounds quite easy. And even if it's like South Africa and South Korea, those countries that have good tech, so there shouldn't be a big problem. So the Standard Bank, which is the largest bank in Africa or in South Africa, did a research together with the Shinhan Bank, which is the leading bank in South Korea. And what they did is try to figure out, like, okay, if somebody from Africa who has a bank account at the Standard Bank wants to transfer money to a person living in South Korea that has a bank account at the Shinhan Bank. So what does that mean? How long does that transaction took? How expensive it is or cheap it is, and so on. So since we have several people here in the live session at Zoom, maybe somebody of you has an idea about how expensive doing such transaction might be and how long it takes to have such a transaction done. So maybe somebody has a guess and will add it to the chat. Let me get some new water. I will. Oh, we have something. Oh, somebody says it will cost $60 to do that transaction. Okay. Any guess about the time? How much hours it will take until the money is on the other account? Okay, no guess so far. So, oh, 2 days. Somebody says 2 days. Okay, so oh, and somebody else says 7 days. Okay, so you're really pessimistic here. So it is like that. Doing such a transaction costs $40 of fee or more. So depending on how much you send, right? So if you really send a very low amount of money, it will be $40. So the fee, your $60 was not a bad bet. It's a little less, but still very expensive. And so you said 2 days or 7 days. Actually, it could even be more because it needs up to 6 business days. And this is not, just days. This is business days, which means if you have a weekend or a public holiday in between of that, it could easily even take 8 days or something like that. And with having a transaction that takes several days, in worst case longer than a week, it's really problematic that this transaction cannot be tracked, right? So you send your money, and 5 days later you have no idea where your money is. I think that's not a really good user experience. Let's call it like that. So And those are the facts those two banks figured out when doing that research. And the reason why it's like that is that when doing a transaction for us as an end user, it feels like, oh, there's just one transaction going from bank A to bank B. But in reality, it's like multiple transactions that are involved in something like that, or in a use case like that, because the money is leaving continents, going around the world. And with that, some special banks, I just call them here global mega banks, because that are not banks where, normal people has accounts on. Those are really the big banks that regulate the money transfer around the world and things like that. And those are involved if you do such a transaction as a person that, leaves your country, leaves your continent, and so on. And while all those transactions today are standardized by digital workflows like the Swift workflow, for example, what happens within a bank is a kind of black box, right? And you don't know how much time it needs to, once the transaction in bank A happens, how long it takes since that bank forwards with a new transaction the thing to the next bank. You even don't know if there's a manual step needed in it, right? I mean, with 7 days, it in theory could even have a manual step in it. I don't know if that's the case, but yeah, it's a black box for us. And with that in mind, those two banks, the Standard Bank and the Shinhan Bank, created a proof of concept if they can make it better. And what they did is they created some like enterprise functionalities on top of the Hedera network, so on a network that is based on Hiero, to solve that problem. So the POC that they created is now a little bit older than a year, like 1.5 years. And what they did is they used something which is called a smart contract. So a smart contract is is code that can be deployed into a Hiero-based network and can then be executed in that network. We will come to that later today when we playing with SDKs, understanding how to do transaction with the SDKs, again, the network, and then later we will see how you can really do like powerful operations on a Hiero-based network. So what they did is they deployed a kind of code in the Hedera network. And what that code does, it manages two types of crypto coins. So when hearing crypto coins, a lot of people might think about Bitcoin, something that you can buy and that hopefully goes all the way up with the price and then you get rich and things like that. So that is not exactly what I mean here in that use case. So what the two banks did, they decided to create crypto coins that are like digital replications of the real currencies of the countries. So in South Africa, you have the rand, and in South Korea, you have the won. And what they did, they created so-called stable coins, which means the value of the coin is bound to a real-world asset, in that case, a real currency. So they created stable coins for the South African rand and stable coins for the South Korean won. Since they created the contract and the program in Hedera who's doing it, you do not need to buy those coins. You can set up this project or this program that it just creates, I don't know, 10 million of those coins, or 100 million or a billion, whatever. And what they then did is they exchanged half of those coins to the digital accounts they had in the Hedera network, meaning each of the two banks has in the Hedera network access to a big amount of South Korean won and a big amount of South African rand. And whenever a transaction now happens in real time, what they did is they did the same transaction on the Hedera network, and by doing so, exchanging those digital tokens, those crypto tokens that they created for their internal use case. And by doing it like that, they were able to do it on the Hedera network instead of going through all those big super banks and things like that. And with that POC, they were able to, do a transaction in less than a minute and having it cost less than 10 cents. And those 10 cents, when talking about the real price, is way higher than it costs in the Hedera network to do something like that. So this is from an Hedera network point of view already quite expensive. Yeah, and since it's part of a public ledger, the Hedera network is a fully public ledger. People were able to do real-time tracking of the transaction. What is, if it needs less than 1 minute, not that important anymore against having a transaction that took like 7 days or something like that. But at least it is possible, which is great. So, and that is just one sample, a real-world sample that is based on a distributed ledger, on distributed ledger technologies. And with that in mind, as an example, I will leave the introduction about DLT, about crypto and all that behind, and now concentrate on Hiero, on the Hiero projects, and so on. So, as already said, what we are doing is transferring the code base of Hedera to Hiero. And that is something that is still ongoing. So we have already a lot of projects, especially SDKs, where we talk about today, being part of the Hiero Ledger organization at GitHub, and with that already having a lot of source code contributed to the Linux Foundation, to the Linux Foundation DT, and currently working on making that vendor neutral. I will show you what that means. I'm just seeing there's a question. Let me see. Oh, there's a question. Thank you for that. Let me just answer that question and go back to this. So the question was, what if those two banks generate more digital currency than they actually have in their banks? So at the end, you can say it don't care, right? Because they do not the digital currency they have created will never be used to buy something. That is, as said, don't think about Bitcoin, where the idea is you can buy a pizza with Bitcoin. The idea here is to have digital assets where only those two banks have access to, that are like replicas of real money that they can use to do the transactions in the Hedera network by doing a transaction with exactly the right amount of money that is needed without, needing to exchange real money. And since they, at the beginning, defined who owns what of the whole digital crypto that is for those two in the Hedera network managed by a smart contract, that problem does not happen because they will never create new tokens or burn tokens or something like that. They just have an amount and use that to exchange crypto coins based on a transaction coming. I hope that answers the question. So coming back to Hiero, and I have a quite outdated picture here of the Hiero transfer. I think it's maybe even easier if I, let me see, just share for that moment my full screen. Boom, here we go. Let me put all of you here on the side on my second screen. And then we can go to the browser. You're seeing now my screen, right? And seeing the browser. Is that
We can see your screen. It says the browser has the Hiero Ledger GitHub.
perfect? Yeah, perfect. That is what I wanted to see. Thank you. Perfect. So um, so I'm here under github.com/Hiero-Ledger, and which meaning we are now on the landing page of the Hiero org at GitHub, and we have the transfer document that gives an overview about all the different projects coming from Hedera that we want to transfer to Hiero, and as you can see, a lot are successfully transferred. And for a lot others, we are now at a point where everything is done without the transfer. So we had some blockers regarding license checks. We checked all the dependencies, the transitive dependencies of those projects to have them clean and follow the license guidelines of the Linux Foundation and Linux Foundation Decentralized Trust. We did DCO checks for each and every project, checking that all the commits are valid regarding sign off of the DCO and so on and so on and so on. So there were a lot of steps and defining user rights for the committers and the maintainers for those projects and so on. That took a lot of time, and now we're at the point where we have cleared that for most of the project, and mostly every week transferring one or two of those repositories to Hiero. And today it's about the SDKs, and as you can see, when executing the Rust SDK, all other SDKs are already transferred to Hiero. So when using our SDKs, which means creating an application, creating some tooling that is based or that is working against an Hiero-based network like Hedera is, for example, everything you need is now part of Hiero. Yeah, that is where we will work with today with like the Hiero SDK for JavaScript, the Hiero SDK for Java, and even our totally new one, which is the Hiero SDK for Python. So with that, I think I can just continue here with that. So to understand all those different projects that are part of the list, what I did is I tried to set up a small, like diagram how all those projects depend on each other and so on. So let's start with the consensus node, which is like the core of an Hiero-based network, because that is what is, for example, running within the Hiero network today. So those in the Hedera network, as an example, multiple consensus nodes are running, maintained and executed by companies like Google, IBM, and so on. And the consensus node, the repo that contains all that code, I hope that we will transfer it next week to Hiero. With that in mind, the really base of everything, the server component that is running the network and containing the hashgraph algorithm and all of that will be part of Hiero in near future. Yeah, and I mean, it's already open source under Hedera today, but with having that at Hiero as part of the Linux Foundation, everybody and everyone can run a network, independent if you are a university or some universities and want to run a Hiero-based network to have your students learn about distributed ledger technologies, learn about smart contract, executing smart contracts in the network you are running in your universities or in your university network, or maybe you are a private company and want to run a private network storing some private information in it, or maybe even do that together with, a set of companies that work together and want to share information in a secure and trustful way. Having the Hiero consensus node is then a real great use case for that, because it's a full node that can be used to set up a Hiero-based network. And we even use in that, some of the people who are here in the meeting might know about it, Bisu, which is another project of the Linux Foundation Decentralized Trust, that is an implementation of the Ethereum virtual machine, which is the virtual machine that executes and handles the smart contracts that are stored and executed on a Hiero-based network. We will see and learn what an EVM is, what a smart contract is, and what benefits you have by using smart contracts as a factor of trust to communicate between entities later when we do real samples by using SDKs on that. On top of that, we have some projects that will be migrated to in the future, where we now solved all the problems with and that are ready to transfer to Hiero, which is BlockNode, Ethereum RCP Relay, and MirrorNode. So these three projects are server-side projects too. While BlockNode will be our standard component to define how blocks are streamed. So whatever happens as transactions against the consensus node will be handled then in blocks by BlockNode and streamed to be consumed by whatever you want to. One thing that can consume it is MirrorNode, which is a node that consumes all the information of transactions happens against the consensus node, and stores that in a database by doing map reduce operations and things like that, which on the one hand makes it quite easy to evaluate the state of the network to see if the network is safe and valid. And on the other hand, allows to query the network quite easy by even using REST endpoints to get information about accounts, transactions, and so on. Oh yeah, and then there is the Ethereum RCP relay, which is, you can think about it as a kind of like converter on top of the consensus node that allows you to use Ethereum clients, like, again, coming back to the Linux Foundation of Decentralized Trust, Web3j, which is a Java client that can be used to communicate with an Ethereum network. And everything that can be used to communicate with an Ethereum network can, by having an Ethereum RCP relay installed for an Hiero-based network, to communicate with that network. Because this Ethereum RCP relay allows you to communicate with an Hiero network by using standardized Ethereum transactions. And on top of that, we have several tools. First of all, the client SDKs. Here are some, and this is not updated, there are more now, some languages for those who we provide in Hiero SDKs. Then we have a web UI, an explorer that you can use, especially that is using the mirror node, so that you can have a look at different transactions, at accounts, and so on and so on. I can directly show that since we are here in this hybrid view. So if I go to hashscan.io, which is a deployment of the mirror node explorer that is part of Hiero, which is the deployment that is done by Hashgraph and that is configured to go against mainnet, testnet, or previewnet from Hedera. To be fair, all that is, the source code is vendor neutral. So this is a specific deployment of the source code that is configured to be easily used with an Hedera-based network. And here you can now see like smart contract calls happened, crypto transfers happened, messages going to our consensus service. Hey, here we have an hello world message, for example, just clicked on it. And so on and so on. So here somebody's sent hello future to any topic in our consensus network. Okay, anyway, we will have a look later at that one. This was just to not only show slides in this first part of the meeting. And then we have two projects, Solo and Local that will allow you to set up networks. So like Local is really just setting up one single consensus node that easily can be used to run tests against it. Solo is way more configurable and provides way more functionality so that you can use Solo to set up a full network if you want, even on a Kubernetes cluster as an example, where you can still use it to create a one node network and run tests against it. So that is a quite nice project, and we will have a look at that today later and use it to set up a network, a temporary network that we can use when creating something with the SDKs to test it instead of going against a real network and executing tests against a real network. So I've seen there are several comments. Let me have a look if there's something I can answer.
We did have a question from Jeff P. This may be too technical a question. What is the established rollback procedure if there are network problems between two parties?
Okay. So I assume the question is like, okay, we have a can I here? Let's see. So we have a Hiero-based network that contains of, let's say, like 5 nodes. They are somehow, however, that look like connected, right? So this is our network. And now somebody, a client, so this is our PC. Don't know if that is, I do what I can to draw it live, right? And this PC sends a transaction to the network. So what this PC does, it don't send like a transaction to each node, it sends it to like one entry point. And now the network from the client view handle that transaction internally, whatever that transaction is, submit a token to another account, do a smart contract call or whatever. And my assumption, what Jeff asks is, so if two parties, which means this party and that party have a network problem, which means like they have a problem here. So that is exactly what is called the hashgraph algorithm that comes into play at this level. And the hashgraph algorithm is an algorithm that is used as a base of the Hiero network to create consensus within the network between all those nodes. As some of you might know, like at Bitcoin, it's, for example, handled like that all the nodes that are part of the network use this mining trick, right? So trying to solve a cryptographic puzzle, like find the hash that has 20 zeros at the end, and create the magic number that when added to a block will end for the hash for this block with this specific 20 zeros at the end hash. That is one of the points why Bitcoin, for example, needs that much energy and resources. And that is not what Hiero is doing. Here, the hashgraph algorithm comes into play to create consensus so that all those nodes that are part of the network use a fair mathematic approach that allows them to create consensus within the network to define a valid state after a transaction in the network in a very, very fast time. I have, and I think it was posted in the chat in the YouTube playlist. I have some videos where I do not start explaining about decentralized ledgers at the level I did here in this talk, but we started with what is Bitcoin, what is a blockchain, and then go like the next step. What are the different mechanisms that can be used to create consensus? And Jeff, so if you are interested in that, I cannot find it now. I need to search for it, but you can ping me and I can forward you, for example, to this video where I talk about that. I hope as a short idea about what is going on here within a network of consensus nodes that is good enough. For more details, there are other videos. And if you want to know it really, really, really detailed, I cannot even answer that question because this hashgraph mathematical and cryptographic algorithm is really, kind of, you need to understand it's kind of complex, and there are good videos from Riemann, who invited that algorithm and who explains it on YouTube. There are several videos about the hashgraph consensus algorithm that you can watch if you want to know more about that. Okay, cool, perfect. So there's another question about where's the code for Solro. Can you talk a little more about how it works and how it's concepted for SDK projects? So if I scroll like 100 slides to the future, we will come to that topic. So if you want to know more about Solro, you need to stay a little bit longer with me here. But I'm happy to talk about that and give more insights on that. So how can I delete everything? Perfect. Everything's deleted. So, and on top of this, what we've seen so far, there's the last layer, which is everything else: application, wallets, integration in frameworks, integration in tools, developer tools. Examples are, for example, DIT libraries that use Hedera to work with DIT. Wallets can be an example. Oh, I said Hedera, sorry about that. That use a Hiero-based network to work with DIT. Wallets that are compatible with any Hiero-based network, and so on and so on. So those are projects where I hope, and where we already started, to work together with the community to create all those projects. And one good sample for that is we had on Monday in the TSC, where TSC stands for Technical Steering Committee, meeting of Hiero a vote that we will add a project coming from the community that is an SDK for DIT integration written in Python, and we will add tomorrow, I think, the technical transition happens tomorrow, that project to Hiero as an example when talking about DevTools. Okay, I just mentioned the Hiero TSC, the Technical Steering Committee. So while the base of Hiero is coming from Hedera, one goal that we have is to create something vendor neutral, something that can be, used everywhere and is not bound to the Hedera network. We created a technical steering committee of currently 6 persons coming from different companies. We have one person, which is Alex Popovich, who is representing Hedera in that steering committee, but next to him, 5 other people representing different companies that in the past worked in Web3, DLT, and to be fair, especially in the Hedera ecosystem. But all of them have the goal to really create a more open and diverse ecosystem and project with Hiero. And currently, we, for example, have discussions to add more people to the technical steering committee, especially people coming from the community and are new to all of that and not directly coming from the Hedera space. And I would say we're in a good shape to get to that point, and yeah, that is an important next step. And if you never heard about a TSC or ask about, wait, is that now just 6 people behind that project? No, for sure not, right? So behind Hiero, when we look at it, I don't know how many people are in it. So 167 people have contributed to Hiero so far, so not only 6. But we have a technical steering committee, which goal is to drive contribution forward, to drive forward that Hiero will be a real vendor-neutral project, and everybody's able to create Hiero-based networks, to move it from a technology point of view in the right direction, and so on and so on. And this is the committee that is trying to drive that forward. And if you are interested in that, we meet every Tuesday. And as every other meeting we have at Hiero, our TSC meetings are public too, which means everybody can attend those meetings and everybody is invited. And I'm really happy that this is working quite well, and more people from the community coming to those meetings and helping the steering committee to make decisions, discuss with us, and drive things forward. If you are interested in that, again, on the landing page of Hiero in GitHub, you find a link to the public calendar of Hiero. That's a calendar that is provided for us by the Linux Foundation. But in that calendar, you will find all the different Hiero meetings. So next week, we will have an Hiero TSC meeting and a Hiero community call. And later this month, we will start with specific SDK contributor calls, meaning like calls for people that are already or would like to contribute to our SDKs. I assume that will be a bi-weekly 1-hour meeting too. And we provide an icon link to the calendar so that you can easily subscribe to it, add it to your own calendar, and get notified when a Hiero meeting happens or is announced. So sadly, this is all on, no, it's very good that it's on the landing page of the org. Sadly, when going to hiero.org, which is like our webpage, a lot of those informations I'm already showed are not here. That is because our landing page is one project that is open source too, under the Hiero org. So when I go to search for a website, here we go. So here are the sources of the website we just seen. And as you can see, for like 4 months, nothing happened here. I hope to get all those information on the website too. If somebody out there who's just here in the meeting or who's watching this at YouTube or wherever later and is interested in contributing to an open source website, just ping me. I'm happy for everybody who wants to help creating our Hiero website and a better home and a better styled home for all that information than the GitHub org landing pages. Okay, so maybe one last point before we move to the real technical SDKs, I think I said it enough, but that is something where I see people still had a misunderstanding with, right? So Hiero is not Hedera. Hedera is a company and has a product which is called the Hedera Network that is using internally all the code that is provided by the Hiero project in the Linux Foundation. And next to Hedera, everybody can now use that code to create and boot a network. But it's not that we renamed Hedera to Hiero. It is not that there is now a Hiero network. No, 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 no. There are more today Hiero-based network where Hedera is one of it, like the Hedera mainnet or the Hedera testnet. But there can be multiple other Hiero-based networks. And Hedera won't go down and be replaced by Hiero or something like that. Hedera will stay as it is, as Hedera mainnet, and so on. The benefit is just that we will be like more diverse, more inclusive, and so on, by already now having multiple people contributing to Hiero. I just put here some of the companies that are actively contributing to Hiero, right? In the past, it was more or less Hedera, right? And now we have several companies contributing to Hiero, working on the source code, helping us to move it forward. And next to that, not only companies, but even individual people. And I'm super happy with that because it's not just here on the slide. What you see here is reality. And so we started in September, which is like 5 months ago. And I'm really happy that we have already new not only contributors, but defined committers. So people that really have within the Hiero org rights to manage and organize issues, review pull requests, and so on, that are coming from the community, who are individual contributors that found Hiero, found it interesting, learned about it in the TSC and community meetings, and started to contribute, which is, from my point of view, the biggest success we can have so far, next to having everything transferred to Hiero and have it a secure and stable project. But seeing this contribution and diversity is, from my point of view, really a big benefit. Okay, so I talked a lot about Hiero, about what it is, where it's coming from, and so on. So before we now go down and really look at one part of it, which is the SDKs, and how you can use them to create applications, create examples, and so on, that are interacting with an Hiero-based network, now would be the perfect moment if you have any questions on all the things I said so far. I would be more than happy to answer those now, or if you have any comments, any wishes on it. So let me see if we have something in the chat. So nothing new in the chat. So
we do have one from Sophie. Who should we? Well, two of them actually. One from Sarah. Hiero code for working smart contract is open source.
The Hiero code for, let me.
For working with smart contracts, is
absolutely that yes. So in this call today, so my goal is that later in this call, we will create a smart contract and use an SDK to deploy that smart contract to an Hiero network and call it. So, and we use only things that are available at GitHub.
Awesome. And I've got a note here from Sophie. Who should we contact regarding volunteering for the website?
So in general, it's not me, since, let me look who's here in the meeting. No. So you can contact me and I will forward it. I would
And
say.
also we've got a Discord, and I believe there's a Hiero channel on the Discord. If you want
Oh yes,
to go to
absolutely.
the LFDT Discord,
Yeah.
you can probably
that is so what you can do. Okay, let's I like that point. So what you can do is, first of all, if you have a GitHub account, you can start a discussion, right? So as you can see, we're trying to use GitHub discussions more and more. We have some that are used as announcements, like this one, which is just the announcement to the meeting we are currently all in. But we have others like this one, where we really started bigger discussions with several people. And I'm happy that, and as you can see, this is like 2 weeks ago, last week. So we just starting to use that more and more. So whatever you have, oh, look, there's even one I have not read because it's from yesterday. Great. I need to have a look at that. So that is a very good place to ask questions, start contribute, and get connected. Then we have, as I said, the in the calendar, the community meetings. So next one is next week on Thursday. The community meetings are the perfect place because we never have a hard agenda for those meetings. I and other people from the TSC try to prepare something for this meeting if there are no questions. But the general idea of those meetings is to discuss topics and questions coming from the community. So that will be a good place. And then, as you said, we have Discord. I currently do not have it open here, but we have a Discord, and that is starting to get more and more traction too. So it started quite with not that much people, so not in the LFDT space, but in the Hiero space. And I would say since 2 or 3 weeks, more and more people starting to join the Discord, and we have channels now for different SDKs, and we have community members who joined, and discussions, especially on the Python SDK, which is 100% coming from the community. All the communication goes over that Discord, and I really like to see it, how the communication is moving more and more to the open.
Cool. I just shared the link to the Discord in chat.
Perfect. Thank you.
Elizabeth has 2 questions. The first one is, how does Hiero compensate or reward contributors? And the second one is, what is the carbon footprint of the average transaction using Hiero and Hashgraph? How is Hiero repaying the environment for its emissions?
Absolutely. So let's answer the second part first. How is Hiero repaying the environment for its emissions? So as said, and here I would like to go back to this slide. So Hiero is the project under the Linux Foundation and not an active running network, right? So Hiero is the project that contains the specification, contains the source, contains tooling, and so on. And Hedera especially is one network that is using Hiero and creating a network. And I'm always try to concentrate on Hiero and do not talk that much about Hedera in those meetings, but I think now it makes sense to just open the Hedera web page and show it. Because the Hedera network is executed by accounts that coming out of those companies where you see a lot of well-known companies, LG, Dell, Boeing, Hitachi, Google, whatever. So companies coming from different parts of the world, coming from different, how to say, like areas where they're involved. Like we have tech companies here with Google. We have Mondelez, who are the people that doing the Oreos, for example. So we have banks here, totally different companies, and they run the network. And against a network like Bitcoin and Ethereum that is executed by private persons, and you don't know how many private persons execute that networks, where they stay, and so on, or if there's a party that owns like 20 or even 40 or whatever percentage of the network. Here it's that the network is really defined by those parties, And each of those parties is running exactly one node of the network, which means on the one hand, we know exactly who's running the nodes. We know what hardware is running the nodes, meaning we can define like minimum hardware and things like that to have the network being as fast as it is. And we can work with all those companies together to run the nodes in clean data centers. And by doing so, Hedera and the Hedera Council is doing exactly that, making sure that, and now I need to find where it is, the website has been updated, is a carbon neutral network, but I don't know where I can find that. Maybe it's on the main page. Which against other networks is a big benefit, right? Because you have exactly, here we go. So here you see how much power one transaction of the Hedera network costs against others, like for example Visa or other decentralized trust technology networks like Solana or Avalanche or Algorand and so or Ethereum. And this is not done by us, right? So this is coming from the UCL Center of Blockchain Technology. They did a research, and this is the outcome. And next to that, as you can see here, Hedera is committed to being carbon negative, which means whatever is created here is somewhere here we have in the transparency part even informations about the carbon offset of the network. So you can find all that because that is the idea of the Hedera network, right? Instead of having something like Bitcoin or Ethereum where everybody wants a network and that has different goals. Bitcoin has a goal to create a currency that everybody can use. The goal of the Hedera network is to create a network that enterprises can use, that entities like legal entities, government or whatever can use by having a fast network that is carbon negative and is defined by big players around the world in different sectors so that problems regarding somebody can attack the network not really exist. And if you want to know more about that, because I don't want to talk that much about Hedera today, as said, so on February 21st, which is in parallel to the ETH Denver conference in Denver, we will have HederaCon, which is the first the first conference for Hedera. And this is a one-day conference happen in Denver. So who's in that area or who will go to ETH Denver? If you are interested in that, you should register for HederaCon. If you're not in that area, as far as I know, a lot of that will be made available afterwards. So yeah. I hope this answers the question. Okay, good. Any other questions, or should we move forward and talk about SDKs?
I don't have any other questions in chat, Hendrik. Let's move
Good.
forward, let's move forward with SDKs, and when we're ready to take another break, I'll capture all the questions for you. Let's rock.
Perfect. Okay. So, as said, the SDKs are the libraries that you can use within your application, either it's a Java-based application, JavaScript, Go, Python, whatever, to interact with an Hiero-based network. And I totally missed to update this slide to, as I name it here, Hiero API. The last one still said Hedera API. And as I said, while all the libraries has already been moved to Hiero, some of the namespaces are still Hedera. Because just moving the sources to the Linux Foundation and to the Hiero org does not mean that it's directly under the Hiero namespace. So we're currently working on that to change the namespace, the package names, and so on, everything from Hedera to Hiero, make it more open for other networks, and so on. So that is an ongoing process where, again, contribution from the community is highly welcome. But this is why, as you can see here as an example for the Java SDK, the namespace of the group ID is still com.hedera hashgraph, will be org.hiero in near future. So when you have an SDK, what you can do with it is to execute transactions against an Hiero network. And the idea is here to provide an easy API that is working in sync mode. So you do not have asynchronous calls per default, but you have synchronous calls per default, which makes it way easier to understand the SDK and the API. And next to that, the goal is, like, if you know one SDK, you know all of them, because all the SDKs that we have, even the new one, the Python SDK that is coming from the community, is following the same patterns how our SDKs work. Which means, in general, if you create a software that is running on a client, maybe a website, on a mobile app, or anything else, you will use the SDKs to send transactions to an Hiero-based network. And the transaction can be, like I said, create a new account, create a new token, assign a token to a specific account, call a smart contract, create a new file in the network. All that are valid transactions. As you will see later, we have different kind of transaction types. And to have an well-defined specification, even over all those different languages that we support, we use protocol buffers. So if you are not aware of what protocol buffers is, it's a standard that, and you can even just Google it. So if you Google protocol buffers, and here we go. So it's a standard where Google, for example, invested a lot in, that allows you to create data specifications that can be then sent over a wire, over a network, whatever, between different entities. So it's a standard, it's language agnostic, it's language neutral, that you can use to define data structures that can be serialized. And Hiero is using exactly those protobuf standards to define what transaction types and what type of metadata within transactions and so on is possible. So if I just copy, let's start with that. So we've just seen here you see an example how protobuf looks like. So the protobuf specification has some keywords like message, optional, string. And with those keywords, you can define a proto, that is how such a definition is called within protobuf, which defines a person. And with that definition, a person can have a name, a person can have an ID, and a person can have an email, with name and email being a string and ID being an integer, a number. And by having that independent definition in protobuf, you can then use that in code, like you see here as example in Java code, to easily create a person with an ID, a name, and an email, and store it into a file. And now you could use, for example, C++ code to read that file and get ID, name, and email out of it. And if you have a tech background, a background as a programmer, you will see the huge benefit that we are directly recalling here methods or parameters depending on the programming language. And we really can check at compile time if anything is working or not. So it's not that we have here any like JSON that we create at one time and then send to the other side, and the other side gets it and says, I have no idea what you're sending here, right? Already at compile time, at compiling the client, we will see if an error happens here. And everything we at Hiero have is specified in protobuf. Again, we are currently here still at Hedera services that will be migrated hopefully next week in the consensus node repository of Hiero. But what we have here now is, let's go back and go to, where is it? I think it's here. Where's the base? I don't know. Let's go just somewhere. And here we have those proto files, as we just seen, with a lot of documentation and things like that. But at the end, it's just a definition of how objects are looking in the connection between clients and servers when communicating with an Hiero-based network. And for that, we have even an online documentation where you can look at all the different types, starting with quite bait types. Let's look into an account ID. So an account ID has 1, 2, 3, 4, 5 different fields. Here you see the type of the field, and here you see for each and every field a detailed description. What does that mean? And if we go more concrete into specific transactions, let's go to a contract delete transaction that, for example, then contains the contract ID, so the ID of the contract that should be deleted. It has a Boolean flag if it should be removed permanently. Now I could even go here to the contract ID, and again, like we've seen for the account ID, see how a contract ID is set up. And in the near past, we invested a lot in this documentation to have that open and allow everybody to use that documentation and use that protobuf standard to communicate with an Hiero-based network. And the success of that, I think the biggest success of that is that we now have a Python SDK that is coming from the community who's using this protobuf specification with this documentation and creating a Python library that can be used to interact with an Hiero network. So this means at the end, when communicating, we sending serialized protobuf data, right? So we sending a transaction that contains those serialized protobuf data that we can, by using a fluent and rich API in the SDKs to create our transaction, then hidden from us, it's serialized, sent over the wire to the Hiero-based network, and in the consensus node where it goes in, it is deserialized to be like based on the specification we have being exactly those objects, and then based on the transaction type being executed. And having this protobuf here really allows us to do not have like malicious data in it, because the protobuf really defines how an object needs to look like, what is allowed in it, what not, and so on and so on. And it allows us to create all those different client languages. Let me see, are there any questions on that? Okay, no questions so far. Um, Good. So let's continue with that. So um, maybe this is now a good point to have a first look at some source code and see how source code that is using an SDK and creating transaction looks like. So let me just open. Let me open it on the other screen because I don't know if a file viewer should better not see where my key is open. Yeah, so let's close it all. Okay, so here I have a Visual Studio client and I have a sample.js. So this is just a JavaScript application that when looking at the package JSON, can I do this a little bit bigger? Maybe like this. So when looking at the package JSON has two dependencies. Here again, we see it. So we already have prepared everything to do our first Hiero release of the SDK. Currently, the namespace is still Hashgraph SDK. Will be in near future Hiero SDK. And then I have another dependency, which is .env, because I have a .env file here that contains my account and my secret to connect to a Hedera network. Because when I start the sample later, I need a network to connect with, and this sample is then just using the an Hedera network as a starting point. And what we are doing in this sample is here, this whole point just reads in the operator ID and the secret private operator key that we use to connect to the network. And then we create a transaction, especially in this case, a transfer transaction that allows us to transfer cryptocurrency from one account to another account. And here we take the operator account and say, okay, this one will be -3 H bar. H bar is the cryptocurrency of Hedera network, if you never heard about it. And then we have two other accounts, one that is defined by 00200 and one that is defined by 00201. And this account gets 1 H bar, this account gets 2 H bar. And as you can see, we have -3, 1, and 2, which at the end is like 0. So that is a valid transaction where 2 H bar are removed from that account, 1 H bar is added to that account, 1 H bar is added to that account. Then we sign that transaction with our private key, because not everybody should be able to send such a transaction and send money from one account to another account, right? So the operator that is losing money here need to sign that transaction, and then we execute that transaction. And in the moment when we execute that transaction, internally the protobuf stuff that we have seen is happening, and things are sent to the Hedera network. And then later, if we go here, for example, to the transaction tab in HashScan, we could see that transaction and then even go into that transaction and could even then see here like the different fees going to different nodes. I think we can do that. Let's see. Let's just do that. And here we see success. So let's see, we used that account. I do a little bit of logging here in the sample. Where is it? Like here, using account, so that I do not need to open the .env so that you see the private key. So that is why I'm just logging it out here. But if I now take this account and go into HashScan and put in the account here, oh yeah, we have already auto completion for it. We see here the latest transaction that happened, which is some seconds ago is a crypto transfer transaction. Let's have a look at that. And here you see what we've seen here, right? So the operator account, which is this one, is losing 3 and a little bit H bar. And then the 200 account is receiving 1 H bar. The 202 account is receiving 2 H bar. That is what we see here. And then we see that there are other accounts who receive like 0.0000001 H bar. And that is the cost of that transaction, right? Because, I mean, in a decentralized network, like in any modern IT infrastructure, it's not for free to do those things. So what you need to do is, for such a transaction that change the state of the network, you need to pay. The good thing is at Hedera, you really only need to pay a little bit. So when looking at that, that is really only, like a very, 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 very small percentage of a cent that you need to pay for that. But what we've seen already now is, hey, we have a JavaScript application here that depends on the SDK for JavaScript that creates a transaction and then executes it. And this is configured to run against Hedera testnet. And here we already see now that the transaction has happened, and we can more or less live see the results of it. Okay, so that is what happens technically when doing transactions. Let's have a look at the different kinds of transactions that Hiero has. We've seen so far a transfer transaction that can transfer cryptocurrencies from one account to another account. But there's more. And oops, what's that? Let's move that to this screen. But there was more, and that is where the Hiero services comes into play. So the consensus node of Hiero is created in a service-oriented architecture. What does that mean? It means that the software of the consensus node is not one big block of code, but it's a modular system that has a base that contains a consensus mechanism and things like that. And then on top of that, you have multiple services sitting next to each other. And the architecture of the consensus node project is written in a case that those services are modular and in theory could be added or removed. So when talking about adding or removing, I'm not talking about adding or removing it at runtime. I'm more talking about like, if you want to use Hiero to set up your own network, you can exclude all the different services you don't care about. If you, for example, only want to care about smart contract, you do not need several other services that have nothing to do with smart contract. Or if you only want to concentrate on crypto transfers, you don't need a file service at all that allows you to create files in the network. So that is one benefit of Hiero, and that allows us to really say, hey, so while the Hedera network has a lot of services, and why today everything that is in the source code of Hiero are exactly the services that are running in the Hedera network, in theory, everybody can create new services and add new services to the Hiero code base, and then a network instance like Hedera can be configured to activate, deactivate, add, and remove services, which is a really big benefit because by doing that, you are able to create a network that really fits your needs. right? And if you want to have a network that does exactly one thing, that is native voting, because you need that in your company or you need it for something else, you can use the Hiero code base, create a voting service, in best case open source, but you could even do it closed source if you want to, and then run that Hiero or run a Hiero-based network with that service, independent if it's coming from Hiero, from your code base, wherever, and have a network that can be used as a voting system. Up to you. And that is a big benefit. And so to be fair, on the server side, when talking about the consensus node, that is already perfectly implemented. When it comes to the documentation and to the SDK, we are still working on it to have it easily extendable, easily configurable. That is something that will happen in future, but where we currently figuring out, especially with all the different languages for the SDKs, what are the best patterns and architectures to do that. Anyway, so when talking about services, the interesting services that are currently part of Hiero are the crypto service, token service, consensus service, file service, and smart contract service. And I don't know if we have time to see examples for all of those. If you are interested, we can have a look at some, and especially when it comes to smart contracts, do really a sample with creating a smart contract and so on and so on. So all those services support different kinds of transactions. When talking about the Hiero crypto service, here we, for example, see the transfer transaction, the one that we used here. That is part of the Hiero crypto service, like account create transaction, account update transaction, transfer transaction, account delete transaction, and account allowance approval transaction. Those are all part of the crypto service. And we already seen a sample for that, especially this sample where we use my account that I have at the Hedera testnet, which is called in the sample the operator account, because that is the account that is operating the sample. And this account then is executing and signing the transfer transaction against the network. We have the Hiero token service, and the token service can be used if you want to create an application that is using any kind of digital tokens, like, for example, any custom crypto tokens. You can use that to create your own NFT type, to create your own coin type. If you want, you can create your own stable coin or whatever, and then use that sorry, to just use applications to create new tokens, mine new instances of that token type, associate token to a specific user, and so on and so on and so on. So that is all part of the Hiero token service. So the big difference is, that is a question that happens often. Here we talk about HBAR, about the native currency that is used within the system, and this is something that can be used for each and any token that you even can. I mean, you can create the token with that system, right? So it's not at all defined what kind of token you are using, because the system allows you to create any type of token. Then we have the consensus serving, and the consensus serving is a little bit like a message bus or an event bus, because with the consensus service, you see you have transaction like topic create transaction and topic update transaction. So what you can do with the consensus service, you can create a so-called topic, and then you can submit messages to a topic. And others can subscribe to the topic and listen to messages. So by doing so, you can use a Hiero-based network to send messages and to, spread messages around different companies, parties, entities, services, and being sure that all the messages you send to the system will at the end be really part of the system because they're executed in a transactional manner within Hiero. And even for that, again, you can use for Hiero, which is a public network, so everything is public, the hash scan, click on topics, and then we see like several topics that has been created. So here you see like topics that have been created within the last hour. Let's click on one. Sadly, no messages has been sent to this topic. So maybe if we go to the dashboard, here we see a lot of, and all those are sent just in this minute. Oh, let's take this one. So here we have a message that contains a kind of JSON file with C, A, and V. Don't ask me what that means, right? That is somebody, I have no idea who that is, sending to a topic within that public network. But that is what you can do with it. Like, for example, sending custom data to a topic and using that to have two applications communicating or updating each other and making sure that the data is available on an independent place, in this case, the Hedera network, and can be verified all the time. Then we have the Hiero file service that can be used to create files in the network. So you can upload a custom file in a Hiero network. There are different use cases for what you can use that. If you, for example, want to store assets for any service or game or something like that, you can upload them directly in your network. Another thing where you can use it is when it comes to smart contracts, because to have a smart contract, a program running in a Hiero network, first of all, you need to upload that network. You need to upload the contract, so the code, to the network. And that is, for example, done by a file upload. And the smart contract service is the last service that provides different kinds of transactions. So that is like the sum of transactions we would like to concentrate on. And in the small sample I've shown, this JavaScript transfer transaction example, as said at the beginning, I have this is going against a Hedera network, and I already said this is the Hedera testnet network and not the mainnet, because the testnet is great to play with Hiero, to learn about Hiero, and to understand how the SDKs and the different types of transaction works. That is where you can totally perfect use the Hedera testnet as an Hiero-based network. And to connect to such a network, you always need to have an account, and that account needs to have a private key. So what I'm doing here, I'm reading from that.env file two parameters, an operator account ID and an operator account private key, into my program, and then using that when sending transactions as my account. And getting that for the Hedera testnet is quite easy. And if you want to do the first steps with Hiero, I would highly recommend to do so. We will see later how you can use Solo to set up a network and run against it. But for just learning it, doing it on your machine, it's really nice to use Hedera testnet. And to get an account on Hedera testnet, all you need to do is you need to go to portal.hedera.com, and there you can create an account. You can just log in, or you can just create an account for free with your mail address. And you can use that account then to interact with the Hedera testnet. And since we've learned when looking at the transaction we did in our sample, so this one, um, here we needed to pay a lot of fees. And that is what happens for each and every transaction, right? You need to pay for it. And we sent even 3 bars to another account. So to play with a network, what you need is you need some money, some bars in that case, to even pay for the transactions that you want to use when playing with it. And the good thing of Hedera testnet is that you get, I don't know if it's 10,000 or 1,000 actually, but I think it's 1,000. But you get a lot of bars every day updated on your account so that you have every day for Hedera testnet enough resources to just play with it and learn all of it. And once you have an account and being like registered, you will see a view that looks a little bit like that. And what you see here then, let me mark it, is your account ID for Hedera testnet. And then you see your private and public key in different variants. The examples that I show you today are using this here at the bottom. So what I have in my .env file is this number and this full key that I just, rendered out some numbers here in the screenshot. And with those two informations, you can more or less run any Hiero sample, any Hiero tutorial you find online. A lot of them are still called Hedera tutorials, Hedera examples, and there will be Hedera tutorials and Hedera samples too in future, right? But with Hiero, it's now more open. But whatever you find in that ecosystem, you can easily use Hedera testnet and your account to play with it and check out how to use those transactions. So let me remove this and let's have a look at some samples. First of all, are there any questions? So, oh
I
yeah, thanks for sharing Portal, and we have here a link regarding the .NET SDK. So, yeah, I mean, it is very easy from my point of view in any language, right? That's why we now will have a look at 3 different programming languages, which is JavaScript, which is Python, and which is Java. And just be aware, I only know Java of them, right? So I can read JavaScript, I can read Python, I cannot code it. So the goals that we have when, first of all, looking at JavaScript and Python is to see how similar the programming languages are. So let me open a new window. And again, let me move that here because I don't know if I have the .env file open in the Python project. And before we need to cut the video to remove something, it's easier to open it here. And exactly, I have the .env file open for sure. So let's put this here next to the JavaScript sample. And just for if you have no idea what a .env file is, right? The Python one has an .env.example. So in theory, it's really just a property file where you say like, okay, operator ID is 1.3.doot and should be not that, should only be numbers like this. And the operator key is, I don't know, something like a very long phrase, right? That is how this .env file looks. It looks exactly like this. With the information, instead of having something random in it, that I have in the Hedera portal when logging in. And this having a private key and an account ID is not specific to Hedera, right? So for any network, you need an account definition and a key to log in. That is just a standard. The good thing is that with Hedera, they invested on testnet to make it really easy. That's why today that is really a good way to show it as an example. What are the best practices when coding an SDK? Do we refer to other SDKs? I will answer that question in a second. I like that question a lot. Let me just, first of all, show you that when I go in, we have here, I don't know, what have we done? We did a transfer, right? Transfer HBAR. So what we see now next to each other, here we have a transfer transaction where we set a memo and where we do like add HBAR transfer. And what we see here, so we don't have a memo, but what we see here is more or less the same code as we see here. So here we have more parties involved. So we have -3 and then 1 and 2. And here we have -1. So that is defined in tiny bar and not using this variant where you put in an HBAR object. And +1, then we do with the freeze. It's exactly the same as here. Then we sign it with our key. It's exactly the same as here. And then we execute it. It's exactly the same as here. And let me open as last example Java. When I find my, I can just open it again in a new window here in Visual Studio Code. So let me open the Java sample. Here we go. Again, very similar. I have a .env file and I have a sample. I don't know what this sample does. I have I have another kind of transaction. I have an account create transaction, but again, it's the same. We create a transaction and then call it execute, put in the client, and we're good to go. So that is what I meant when I said the goal is if you know one SDK, you know all of them, because we try to follow the same pattern. And to make it more easy for the community, to coming back to the question from Sophie, to make it more easy for the community to create new SDK and create new content, next to the next to the documentation of all the different protobuf objects that from a very technical point of view gives them information how the standard of communication between any client and a network looks like. Our plan is to go a next step, and for that I opened a discussion where is it? Yesterday. And what we want to do is we want to create for the SDKs specific documentation that gives an overview about the functionality an SDK should provide. And for that, we currently have a PR open that contains a draft for a template for that documentation. So that is, just an idea. Let's say we have something new. You can define the new API, define the new variables, define like in what range, min, max, required, optional. All that should be, you will add a summary. You will define what APIs should be updated. You will define a test plan, how an implementation for an SDK can be tested. You need to add examples to it. And the idea is whenever something new comes to an SDK, or it comes to the general definition, we will create SDK design doc for it, create issues in all the repos under Hiero that contains SDKs, and link them here so that we have an overview. Hey, here is, for example, a new parameter being added to a transaction, and here are all the issues for the different SDKs to solve that new parameter and to add it. And I assume that is with the SDK contributor meeting that we will add as a bi-weekly meeting. One important point to move the SDKs, especially with outside contribution and with contribution from the community forward. And to check that an SDK is valid and is doing the correct thing. I mean, we have here defined a test plan, but a test plan can test the wrong thing, right? So to make that sure, we have a TCK, which is called the Test Compatibility Kit. And the TCK that can be found under the Hiero org. Where is it? Hiero SDK, TCK, somewhere. Here we go. So this contains SDK independent tests on SDK independent test plan that in a best case contains all the different functionalities an SDK can have, and that then can be executed against any SDK. To do that, an SDK needs to implement a bridge to the TCK. The TCKs that are coming from Hedera, like the Java SDK, the JavaScript SDK, the Go SDK, already have that. So you will find in those SDKs, let's go to the C++ one. Okay, for the C++, I have no idea where it is. Let's go to the, let's see, for Go, do we find it? Here, in Go, you find the TCK folder, and this one is like the bridge between the Go SDK and all the language agnostic TCK tests, and that can then be used to run the Go SDK against all those tests. And with the TCK on the one hand, that can be used to always test if what you have done is correct based on how we specify the configuration, the communication. With the documentation of the protobuf objects that will end in having source code that you can easily, compile and use in your project with something we have not looked in at all with the documentation. So I'm currently here under docs.hedera.com. But since last week, we have, where is it? Somewhere here's docs, Hiero docs here. We now have the docs at Hiero, so we will have docs.hiero.org in the future, and there we move everything that is Hedera specific, which means at the end we will have a very good documentation of the SDK functionalities in the docs, and next to the functionalities, even a very good documentation on how to use the SDKs. Let's go again, for example, to the transfer transaction we've seen, where we now find, again, a full documentation about all you can do with it, and currently sample for Java, JavaScript, and Go. And we already discussed how we can make it easier to add tabs here for all the different languages. So we have the end user documentation that contains how an end user should use it. We have the API docs for new features coming to the SDKs, and we have the protobuf documentation. That is the idea that we will provide for SDK contributors, committers, and maintainers to move the SDKs forward in a way that everything fits together. And then next to that, we will have the SDK contributor meetings every 2 weeks. And with those points, I hope that this is a very, very good, thing to help people create new SDKs, add features to the SDKs we have so far, and so on. And if that is not enough, if there are still questions, you can always ask in the Discord. You can always ask at GitHub discussions. And what is super important, if you have questions, please do that. Because if we see that a lot of those questions come up, we see, okay, there is something where we need to get better, right? So what we're currently trying to provide with all that documentation is our guess that will help the contributors coming from everywhere to contribute to the SDKs. If that is not enough and something else is needed, we definitely be happy to create that. Somehow I have too many windows open. Yeah, here's the chat. Attention, recording will stop in 2 minutes. What? Is that correct? No.
Hendrik, I'm checking that right now because I'm not seeing.
Okay, perfect. Thank you.
But thank you for ever posting that. Let me make sure. We do have a question from Sophie.
Yeah, I'm just looking question for another time. Can you show the Hiero Discord? I went to the Discord page, and in the LD Decentralized Trust, I can see a sidebar for Hiero. I can show it. There's nothing hidden in it. So I'm new to Discord. That is my problem. I clicked somewhere on an invite link, and then I got invited to the Linux Decentralized Trust, and I can show it here, to the Linux Decentralized Trust server at Discord. And in that, you can see here, there's an Hiero section with already several channels, like for example, that is super new, the Hiero SDK for Python, where as I said, the community has already started to discuss several points. And yeah, I still need to look more often into it because I'm seeing people try to ping me on Discord. As said, I'm new to it. You can't see those. Yeah, I don't know. Sorry about that. So that's a good question. So if you don't see those channels for Hiero, that I created them. Maybe I did something wrong here. Um, I will check that with the people from Linux Foundation who know more about Discord than I do. But the idea is that everybody sees all those channels, to be sure. Um, okay, so yeah, I think I answered those questions. Play music? No, I don't want to play music. Go away. Um, so I think I've answered all those questions. So I have some more points. We can look into it, but we're already quite fine time. So what we can have a look at is like, what is a smart contract, how to create smart contracts, how to deploy them by using an SDK in a Hiero-based network. We can have a look how you can use Solo to easily set up a network and run tests against it. We can have a deeper look at the mirror node and how you can use that to get information out of it. So those are all topics we can talk about. Maybe some of them we can even do like in a later session next month or in 2 months, whatever. Happy to do that again and then continue it or talking about another specific topic. So maybe what makes sense is to give a short overview about all of that. Since that is recorded, and then maybe for deeper questions, people can directly ping me on Discord or GitHub discussions. Can't say that often enough. So I talked a lot today about the Python SDK that is coming from the community. When I go into that repository, here we go, Hiero SDK for Python. One very cool thing about that is that this is already using Solo for tests. So that is not like running tests against any Hedera network like Hedera testnet or something like that. No, it uses Solo coming from Hiero to set up a vendor-neutral Hiero network and run the test against that. And how that is done, even like in an automatic way, is that we are using GitHub Actions here. So GitHub Actions, for people who don't know about it, is a tooling, a functionality that you can use in GitHub to automatically execute tasks, like, for example, run your test, run checks, and so on, whenever something in your repository changes. Like when anything is committed to master, or like when somebody creates a pull request, then you can run it on that pull request. And GitHub Actions are always defined in the github/workflows folder within the repository. And there you have YAML files that define the GitHub action. And in the Python SDK, we have an action that is called test.yaml. And what this does is it tests the full Python SDK and all the functionalities of the Python SDK automatically whenever a pull request is created. And what this does, it installs some Python stuff. So this is all setting up Python, installing the dependencies, running our generate proto, which creates Python code out of the generic language independent protobuf definitions. And then it uses it uses an old version. We need to update it because that is always called Hiero Solo action. It uses the Hiero Solo action, which sets up in this GitHub action a full Hiero-based network for you and creates an account for that network, which has, I think, 1 million HBAR, so which has enough to really even run heavy tests, and stores all the information for that account like the account ID and the private key in environment variables. And by doing so, you can use these three lines in any GitHub action to set up a full network and just access those environment variables depending on what you want to do and run your test with those environment variables. And the GitHub action takes care about removing the network, destroying everything once the tests are run, and so on and so on and so on. And by doing that as an application library tool or SDK developer, it is super easy to just write tests, create a pull request, and then in the pull request, see if the tests are all clean because they are automatically executed against the Hiero network. So let's go. I have no clue if this now looks good. Let's go into a pull request here. And here, oh yeah, here we see Hiero solo integration tests is green. We can go into details. And here we see the prepare Hiero solo. We can open that. It's a lot of logout that is super specific. There's a kind network setup, kind of a fake Kubernetes using Docker internally to set up a huge network, then setting up some nodes there to have a Hiero-based network. But the interesting part is this one, right? And we can see the code for this. I go back here to the action. After the Hiero solo action is set up, where we just say run some echoes, which is a command on the Linux shell to print something out. And here we print out, okay, our operator ID is this variable that is coming from Solo. Our operator key is this variable that is coming from Solo, and then we have a private key too. And that is exactly what we see here, right? So we see in this action run, a network has been created. In this network, an account with the ID 001001, and this private key has been created, and I can now use those informations, like the informations in an .env file locally on my machine, to run all those tests against a real Hiero-based network. And as you can see, setting up a full network, even under a normal GitHub action node that is run somewhere by GitHub and shared between, I don't know how many projects, right? That is one of these low cost, no cost GitHub action things. It took under 3 minutes to set up a full network that you can use with as many tests as you want to. So here we run for half a minute a lot of different tests, because with the setup that we created here for the first time in Hiero together with the community, we were able to really create a lot of different tests. Like we have for each and every transaction type, different integration tests that are executed against that Hiero network. So where I'm currently working on is where we now have this as a GitHub action. And next week, I had a meeting today that next week the Hiero solo action will be transferred to Hiero. So it's already, as I said, it's already renamed. Do I have it? Anyway, it's already renamed, but it's not transferred, but it will be transferred next week. Let me show you the Solo action. Here it is. So I said it's already called Hiero Solo action. And it will then be even visible on the GitHub marketplace so that everybody can easily integrate it into a GitHub action and run those tests. Perfect. So, oh, and here you can see that this already provides some different configuration variables. For example, you can say, hey, I want to have a JSON RCP relay installed because what I'm currently doing is creating an application that is using Ethereum transactions that should be run against a Hiero-based network. And I would like to test if those application that is using Ethereum transaction is working with a Hiero-based network. Then you can set up a solo action, said, yes, I want to install a JSON RCP relay. Then the setup took a little bit longer. So currently it was like 3 minutes, maybe then it's 3.5. And then you have an endpoint where you can send Ethereum transaction against. And those are then executed in the Hiero network. Okay, so that is what we have for the GitHub action. Next step is make that easy on my machine too. So we have does solo work when you need to set up the network on a separate machine than you are developing from? Yes, it does. I'm use someone other than localhost in the book of notes from Burnout. So I would say yes. I'm not somebody who develops solo. I'm developed, for example, this action by using solo. I'm currently working on setting up a Docker-only solution for your local machine that you can easily start on your local machine and do run tests locally without needing to install solo and everything that is needed for solo. The idea of solo is that you do not only use it for tests, but that you can even use solo for a real network to be configured and to be maintained and executed. And with that in mind, I would say it works definitely, Jason, what you ask. But I'm not the solo expert. I'm a solo user. So and trying to find good solution on top of solo that makes that ends in a good developer experience, which makes it easy to start with, especially for tests. But my assumption is yes, that should work without a problem. So there was another question: is the Hiero website open source at the moment? So for sure. The Hiero website, I assume the question is about this website, which is under hiero.org. I said it earlier in this meeting that this website is currently quite static. A lot of information is currently under our GitHub org, like, for example, the link to our public calendar that we have now, and so on. And I would like to add all that to the Hiero website, and that is easily possible in theory because the website is 100% open source. It's based on Hiero, which is a static site generator that is, I assume, quite famous. It's this one. It's the world's farthest static site generator, which is open source too, and we use that to create the website to make it easy to create new content by adding markdown files. So the thing that is missing is to have it more dynamic, like easily add new points to the menu and so on and so on. So if somebody out there has knowledge about Hugo, has knowledge about static site generators, I'm happy for any contributions here, happy to create a meeting, sit together to move that forward. Yeah. So coming back from the website to Solo and our use cases. So yeah, as said, and what you can already do today, so Soro is currently a project under Hedera, so it's in the Hashgraph repo. It will be moved to Hiero in future. It's currently not the next one because we want to first of all move everything that is really needed to run a network and that is touring around it, but it will be moved to Hiero. And you can already today install it on your machine and then use it to create a network on your machine or on any machine. And the documentation, again created with Hugo, is quite new and now creates a getting started guide and an FAQ. And that is new documentation. Since this tool is quite new, the documentation is quite new, and we're getting better and better here. And again, I assume that is a point, especially on the documentation and then on the GitHub action and maybe on having a Docker container around it and so on. Contribution and help is more than welcome. Okay, so with that in mind, we can now use SDKs, create some small code that does some transactions against a Hiero network. We use Hedera testnet for it as an easy example. We used Solo on it to just set up a network and run tests or run anything against that network in GitHub Actions. The next step will be to super easily use Solo on your local machine so that you can even sit in a train or in a plane where you do not have Wi-Fi and code on an SDK and run all those tests against the local Solo instance. So let's go to the next level and have a look. With all that, what can you really produce? So what can be the, a little bit bigger application? And as said, I'm coming from Java, so the samples that come now are all Java. Sorry about that. But in general, you can do it with any language. For that, we have an SDK, and if we don't have an SDK for that language, you now know how to create one. So let me open IntelliJ and open project. Oh no, it opens the end file. Oh, I moved it back. Okay, so and open a project, which is an Spring Boot application. So let's close all the other things here. I don't want to save whatever I did here. Let's close that one too. Okay, so what we have here is a Spring Boot application. Spring Boot is, for people who are not coming from the Java ecosystem, an enterprise framework in Java that can be used to create web applications with Java, like microservices, services, web front ends, REST endpoints, whatever you want. And what I'm doing here is I'm creating a small application that has just one view. And let me start that application. So this application again connects against Hedera mainnet. Hedera testnet. And what it does, it has a super easy front end, and I have a table and I have 3 buttons: mind NFT, burn all NFTs, and refresh. And what I can do now, let me just click several times on mind NFT, boom, boom, boom. Oh, there are some already coming. Now let's click refresh. And now you see Now I have several NFTs, right? So I now created for a given NFT with that name is so if you are new to NFTs, let me explain that. An NFT is defined by a type. Like this is the Hendrik NFT. Let's call it like that. And this is this number here. And then you can have instances of that NFT. And the instance is the serial. So a unique token is name plus serial. Let's assume you play a computer game that is using NFTs. And in that computer game, let's say it's something like Pokemon, like a card game, right? And there's a card which is the, I don't know, the fire train, okay? So the name here could be, that is the fire train card. And there are only 10 of those cards exist, which means for that name, we only have 10 serials. And those combination out of name and serial makes one unique fire train, and that is then owned by one person. I have not added the owner here because I just mined them all under my account to show it simple, right? But this is a super minimalistic NFT application, just showing I have a name, I have a serial, and I show it. The good thing is, again, I can copy that, go to hash scan, and search for that. We already see that it's a token. And so if I would add to the metadata of a token something that is a graphic, we would even see the picture here. So if we add a PNG to it as metadata, we would even see it here. So this does not provide image data, so we don't see it here. But what we see here is this is the one with serial 1 that has been created 2 minutes ago, right? And we have not only the one with serial 1, we even have the one with serial 2, 3, 4, and 5. So currently we have 5 instances of them. And as you can see, the owner is always the same, right? Because in this program, I just created it. I'm the owner. Everything is fine. If we now look at the documentation, and go to the SDKs and then go to the transactions, to tokens, what we did here is one token create transaction to create the token with that ID, and then do token mint transactions to create those instances. We could now do where is it? A transfer, let's go to Java, a transfer transaction to transfer one of those tokens where we then have the token ID and the serial as unique identifier of that token to another account if we want to. All that again can be found here in the documentation or in the protobuf documentation for the transfer transaction information. Another thing is I can do a burn NFTs transaction, which will delete all of them. So if I do a reload here, we see they are all going now. Now are all gone. Why does it take some time? Because testnet is slow. That is just the answer. The Hedera testnet is used to play with it. So it's not fast. That is why everything takes some time. It don't have that much resources and so on. If we go back to the treasury account, what we see now here is token create, token mine, token mine, token mine, token mine, and then token burn, token burn. Here we see all the transactions we've now just called by clicking a button in the UI. And that is a simple sample that we can use to that we can use or how we can use SDKs in an application, like in a web front end or in a web application. Okay, so one thing we have not looked so far at, there are several things, but one thing I have prepared we haven't looked at is smart contracts. And I assume since the question already happened twice in the chat, I assume that is where people are interested in. So let's spend some time on that topic. I hope it's fine if you give me like a 2-minute break to drink something, because we already now are in this webinar for over 2 hours. But I'm really happy. I mean, when I look at the list of people that are still here, I'm super happy. So thank you all for being here and staying here with me. Thank you so much. So while I have a glass of water, are there any questions on all the topics we discussed so far? Because then I can react the moment, read those questions, and answer them afterwards.
If you've got a question, feel free to either put it into chat or use the raise hand button under React, and you can ask the question directly to Hendrik.
Absolutely.
And again, to double down on what Hendrik just said, thank you all for sticking with it. We do appreciate it. Oh no, sorry, I thought Robert had a question. He just gave a thumbs up. Thanks, Robert. All right. I guess we can keep going if you're good to go, Hendrik.
Yeah, give me like half a minute,
Yeah. No.
and then we're good. Yeah.
Take your time and enjoy the water.
I think I can already open in the background what I want to show. Okay. So let's talk about smart contracts.
All right, Hendrik, you've just pulled up a screen which has project and all right, you're good to go.
Sorry?
No, I was just checking the screen that you were sharing. You're good.
Yeah. So let's talk about smart contracts. So what is a smart contract? If I go back to my slides, I have like one, I don't know, endless slides about smart nodes. That is the wrong one. Where's the slide deck? Here we go. I have like endless slides about what are smart contracts, how to write smart contracts, and so on. Maybe we just do a short introduction on that topic and then directly go into the code. So smart contracts are a technology that is coming from Ethereum. And the main new thing that Ethereum brought up as a feature to the distributed ledger space, Web3 space, however you want to call it, is the EVM, which stands for the Ethereum virtual machine, which is a virtual machine that allows you to execute code within a distributed ledger. Let's have a look at an example. So the good thing about it is that the Ethereum virtual machine is a state machine, which means it can work like any program that you as a software developer normally write. It has states, it has transitions, it has an initial state. You can think about it like, Mario here switching its state based on what happens. And that is what we as software developers normally code, right? So our application has a state, then something happens, maybe I press a button or Mario gets a mushroom, and that changes the state. In the example we've seen like 5 minutes ago, changing the state was, hey, we mined an NFT. Here for Mario, it means, hey, Mario is getting big, right? So it's really just changing the state of an application, which at the end means the EVM internally has a world state, like a state of everything that is in the network. And when a transaction happens, the state of the network changes based on whatever this transaction does. And the good thing with the EVM is that you now can write code. There are different programming languages that you can use, like Solidity, FE, Viper, and so on, that allow you to create smart contracts. And that code will be compiled in bytecode because the EVM is not specific for a given language. It has a bytecode specification about what can be executed in the EVM. And that bytecode can then be deployed to the EVM and then executed internally in the EVM. And if you are aware of how other virtual machines work, like the Java virtual machine, or how in general bytecode of, so machine readable code looks like, what you often have is so-called opcodes, right? So, and it's the same here. So the bytecode is compiled into opcodes. And an opcode can be like, I want to multiply two numbers, I want to subtract two numbers, things like that, right? So all this basic math tech state changes that you can think about, all that are defined by opcodes and then part of the bytecode. And the interesting thing of the EVM is that next to a definition, what an opcode does, like adding two numbers, subtracting two numbers, or things like that, it contains an information about gas. And gas is a definition on how expensive that opcode is, which means those are not realistic numbers, right? This is just for an example. With that example, it would mean like adding two numbers is way cheaper because it costs 3 gas than multiplying two numbers, which costs 5 gas. And when executing code in a decentralized network that is using an EVM, each execution costs the gas that is calculated by executing all the different opcodes of the code execution. And at the Hedera network, for example, when calling a smart contract, you pay H bar that is then subtracted from your account based on how much gas the execution of the smart contract costs. So, how to write smart contracts? As said, there are different languages. We will concentrate on Solidity, which is, from my point of view, the most important language when writing smart contracts. It is still a quite new language because the whole concept is quite new, right? We don't talk about something like Java or JavaScript that we have since 20 years or something like that. We're really talking about super new technology. So I won't say that Solidity will be the biggest language ever to create smart contracts, but so far it looks like that is the language you should use. And you can find it under soliditygang.org. And when we just go to that web page, dtgang.org. Again, it's open source for sure, right? So everything we see here is in my session is open source. A very good thing about Solidity is that it has a really, really good documentation. The full language is documentation, first of all, in a very complex way, so that you can really do a deep dive and understand all the internals of the language. Next to that, by providing things like cheat sheets that helps you quite easily to see like, okay, what can I do with a string, with an address, and so on. So you have really like different levels of the documentation that makes it, from my point of view, quite good to understand and to use. And this is a sample of a smart contract. So if you coming from Java, from TypeScript, from any object, more or less object-oriented language, what you see here is quite familiar for you. Because a smart contract is more or less always something that is quite similar to a class or to an object definition in the languages we know since years. So what we have here in the contract is a version pragma where it starts with, which says, hey, this contract needs Solidity compiler version 0.7 or higher, because I'm using information here in that language that is new in Solidity 0.7 as an example. Then it defines the contract. We have the keyword contract, and we just name. Yeah, hey, Asa, do you have a question? Oh, okay, it was by accident. Okay, no problem. So contract is a keyword, and we call our contract coin. Then we have some variables, like we know from other languages too. Events is a little bit more specific. Let's skip that. But what we have is constructor, right? So like we know from object-oriented, where we say like, hey, we have a class, and when an instance of that class is created, the constructor is called that might initialize our state variables and so on. It's more or less the same here. And then we have functions that can be called. And those functions are exactly what can be called from the outside. Like when this smart contract that we see here is deployed to an Hiero network, the mind and send function can be called by using a transaction. And a smart contract in a network like Hedera, which is a public network, is available to everybody, which means if you want, everybody can call that function. Here you see that I'm using already something which is best practice for smart contracts that, whoops, sorry about that, that at the beginning of the functions, I do a requires where I check things, especially here. So this is like a fake crypto coin smart contract, which has a mind function to mine new coins. And this checks if the sender of the transaction that is calling this function is equal to the minter. And the minter, that's a nice trick, we have this here as a state variable, is the sender of the transaction that calls that smart contract, which means is the owner of the smart contract. So by doing so, we can easily check, does the person who currently calls that is even allowed to do it, or do we just throw an error back and say, hey, you are forbidden to call this mind function. For sure you can call send, that is fine. We check if you have the balance, and then you can, and then we send it to somebody else. But you cannot mine new code, new tokens. That is only allowed by this Minter account. Don't know if that makes sense, but I think it's a good sample to show like how a smart contract can look like. And what we can do is I'm still in this painting mode. Sorry. And what we can then do is, give me a second. Whoop, whoop. Okay. And what we now can do is take that smart contract and compile it by using the Source compiler. You can download that one from the Solidity page. You can get a Docker image that contains the Source compiler to get bytecode that you then, that is, if you want to run it with the native Source compiler in a shell, you say, okay, Source is Solidity compiler, create bytecode. This is the output folder, and this is the .sol, the .solidity file that you should compile. And once this is done, we have an hello world.bin in this contracts folder. One nice thing about Solidity is that it can create more than a binary output. There's, for example, the ABI output that creates a which is called Application Binary Interface. That is where ABI stands for. And what that does is it creates a JSON representation of your smart contract that you can then, for example, read with any other program to understand what kind of functions does the smart contract have and what functions can be called. Which means we have different things we can create with the compiler. We can run it with Docker. Okay, so let's create a smart contract. Let's say we have a smart contract that just says hi, right? So we have a method here, say hi, and that just returns hi. So return should be lowercase r. I'm just seeing it. It's a typo. But we can write that in Solidity. We can compile it to get a binary code. And then we can deploy that contract to our network. And we do that by using the SDK and calling transactions. And once it's deployed, what we get back is a unique address. And that is the unique address of the instance of that smart contract in that ledger, which means I could deploy the same bytecode 10 times in a network and then get back 10 different unique addresses, each of them for one instance of that smart contract. And when calling about instance, if we go back to this one, the state variables, like the Minter, and here's this mapping of address to how much coins you have, balance, is per instance, right? So you could take this one, deploy it 10 times for 10 different coin types, for example, and then each of those instances has really its own mapping, has really its own Minter. Yeah. When you come from a object-oriented perspective, you can think about each of that is an own instance of the class that is deployed in the network. And when you deploy it, what happens? At the moment of deployment, the constructor is called, right? So you do not like upload the code and then call the constructor by hand or something like that. When you deploy a smart contract, the constructor is automatically called, which allows you afterwards to have the state variables for that instance under that unique address already been specified. And then you can use that unique address to call specific functions on that smart contract instance. Okay, how to do that with the SDK? So the first thing we need is we need to upload the bytecode to the network. To do so, we use the file create transaction. So that is from the file service. That is by default part of an Hiero network. It's part of the Hedera networks. It could be removed if you want and you don't want to use it, but if you have smart contracts, it definitely makes sense. And what you are doing is you creating that file. Again, we create a transaction, we call an execute on that transaction, and on the response, we can then get the file ID, which is the unique ID of the file instance with that bytecode that we put here into the file create instance in the network. And then we can say, hey, we have this file ID. Can you please create a smart contract out of that bytecode? And what you then get back here is a contract ID. And by doing that, if the contract had a constructor that is called with this execute here, this in the ledger, not on your machine, in the network, calls the constructor of your smart contract. And now it's so important to come back to the point of the opcodes, and that each opcode, independent if it's an add or whatever, costs gas. Because if you create a contract that has an infinite loop already in the constructor, and you compile it and upload the bytecode, and then execute the contract create transaction, the constructor will be called, and directly with each of that opcodes, gas will be created up to a maximum of gas, and if that is reached, it will fail. So that you cannot, with an infinite loop, destroy a Hiero-based network or something like that. And that is when you call a contract, what you normally do is you define how much gas in maximum that call should cost. So you have like a check for you that you, by doing an error, not running out of all your money or something like that, you define, okay, that is the maximum that this call should cost. And then in this case, the create method, if that method is part of your smart contract, will be called. Okay, we had that. So let's go into the code. We have a smart contract. So we skip Hello World and go directly to a more interesting one. So I have a smart contract, which is already a little bit longer. Let's see what it does. So this smart contract defines a data structure that contains hashes and has a supply timestamp and a verify timestamp. Then we have a supplier and a consumer. That should maybe be called verifier, would be better. Anyway, let's call it like that, which is of type address. And address is really like an account, right? So, and when calling the constructor here, we put in the constructor already who is the supplier and who is the consumer. And then later, when looking at methods like this add hash method, we check like, hey, is the caller of this message our supplier? Otherwise, we throw an error. That is how we directly have here a smart contract. And when it's deployed, we can bind it to two specific accounts in the network. And then only those two accounts are allowed to call some of the methods. I'm just seeing other methods. Oh, that is a private one. That's why I don't do the check here. That is a public one. A private one is something you cannot call by a transaction. You can only call it, like, from under other questions within this contract. So it's called here in this public one. And this public one, I'm again doing this check. So anyway, what is that smart contract doing? So the idea behind this smart contract is we have two parties and they want to share data. And this is about contracts. So we have parties that have contracts. And this contract contains a lot of data. Maybe this is contracts about test data or whatever. And in the past, they had PDFs. So in the PDF has like 3 pages. And that is a contract for one item. I don't know, a ball. So we have a ball, we have a tennis ball. Let's say we have a tennis ball, and this tennis ball is tested. If it's a good tennis ball and a valid tennis ball, and the test is stored in a 3-page PDF. And now the tennis ball manufacturer sells this tennis ball to, I don't know, Wimbledon. Okay. And for Wimbledon, it's important that this tennis ball fulfills some specific standards. And to know this, we have those test reports, right? So with that tennis ball, now the manufacturer needs to supply those PDFs to Wimbledon, to the tennis court, whoever buys the tennis ball. And now they do a very important match here. And in this match, the ball explodes. I don't know. I don't know if it makes sense. So, and to see if that was an error done by this company that we call B, or by the company who creates the tennis ball that we call A, we need to take a look into the test data. So, since they send the test data here, in theory, both can look into this test data. What could happen now is, and that is the worst case, if one of those twos fakes the test data or change it, right? So let's assume B says, the test data looks good, but we don't want to pay for it. So let's fake the data, change something in it, and say, hey, look here. So those test data that you send us says the ball was not tested at all. So I cannot say, yeah, look, our data says something different, and then they can start arguing against each other, but there is no winner, right? Because there is no real choose. Who is correct? Is it this one or this one? And what this smart contract now does is, hey, let's create a hash out of the PDF, a hash. And A is storing this hash for the identifier of the PDF in the smart contract. And when B receives the PDF, it verifies that they received a PDF, and when hashing it, they get this hash. And if this adds an identifier that is not in the smart contract, it's most an error. If this sends an identifier where the hash is different to the hash that the supplier added, it throws an error. So the only possible way is that a supplier added something where the consumer has not added a hash for and verified the hash, or the supplier added something and the consumer already verified the hash. And with that in mind, we can now very easily check if for a given entity identifier a given hash is correct. Because in that case, if that identifier exists and is verified by the consumer, we can just check if the hash is correct. And we have some nice methods like get total count and things like that. So that is what this smart contract does. And what we now can do is we can compile that smart contract and deploy it into a network. And for that, let me just check if I'm loading an env file. Good. So for that, I created an easy application. And what this does, it at the end updates the env file so that we do not need to look in the env file at all, because what this application does, it creates a new account, which is a supplier account, creates a new account, which is a consumer account, uploads the contract, and then stores all those information, like the contract ID, the supplier account, supplier private key, consumer account, consumer private key into the M file so that we get all this information, but we don't need to look into this M file at all to, once it deployed, run something else. And now we see account create transaction, we create the second account. Now we start to upload the compilation of the smart contract, which starts with a file create, and then we do some file append transactions because a transaction has a maximum size. And if we want to upload a file that is bigger than the size, we need to upload multiple chunks. And those chunks are splitted in file append transactions. In the lowest level, you need to do that on your own, but we already have convenience methods and help functionalities that allow you to do that in a more easy way. Then we create the contract, and once that is done, we can delete the file because the contract is created out of those bytes that we uploaded, so we don't need that file at all. And now we have everything written in this env file. And what I can do now, I have another application that I can start. And this application now has a front end. I see my H bar. I see how many transactions have been done and how many verifications have been uploaded. So we have 4 uploaded verifications, 5 now, and 5 of those 5 are missing. What I have not done so far, because I don't have time to prepare that for this meeting today, is create another application that reads what items are missing for verification and verifies them with the same hash. So sadly, I've done here with the provider side and creating a nice application where you even see like that the H bar is going down with all the transactions happen and so on. What I have not done is creating the other side, which is the consumer application. But I think the idea, what we're doing here is clear. Let me see, are there any questions in the chat? Don't look like that.
We don't have any new questions in the chat yet.
Perfect. But people are still here as far as I can see. That's good. Okay, are there any questions regarding smart contracts? That was just I know, a very short introduction to the topic, but we deployed a contract, we looked at the contract, and we called that contract. And I mean, what we can do now, can we? Oh, I said we do not have logging about. Give me a second. I will take a look at the env file here and copy the contract information. Here we go. And now we can go to this one. Oh, yeah. And see, oh, that's a contract. Great. Okay, so here we see the contract that we had. And here we see that several calls went on that contract without an error. So now I can even click on one of these calls. And now I see the transaction of that call. And I can even, I'm not using that for transactions a lot, but I know there is even a way where I can see like, okay, I see here input parameters, but maybe that is just the request about here, here we see it. So here we call, for example, get total count on that request, and we see the result can be a really long number, but it's only 7, right? So here we see how one of those contract calls are really happened. And here we see the cost. So the cost was 0.00000038 hbar for calling that get total count at that moment. Good. So I think in general, that was mostly everything I have prepared. One thing we can have a look at where we're currently working on, I'm happy to show that, which is in this repository. Yeah. So if you're coming from Java, but we hopefully will do the same for JavaScript and others in future too, is providing a very good integration in enterprise framework. So we've seen with this Java, Python, and JavaScript sample how you can easily use the SDK to do transactions by hand. And when you have a huge application, a huge enterprise application, for example, written in Spring or in microprofile when coming from Java, or maybe in Angular or React or Vue when coming from the JavaScript side, normally you do not want to do all that by hand. You want to use the patterns you know from those enterprise frameworks. And I'm currently working on a project. It's called Hiero Enterprise. I assume it should be Hiero Enterprise Java because this is only Java, and I hope to do the same for JavaScript 2, which provides integration for Hiero functionalities into enterprise frameworks. And this one does it for Java and then especially for microprofile and Spring. And what you can do with that is instead of working on this lower level where you have transactions where you work with, here you work with services like you normally use when creating enterprise applications. So this basic Spring application, what it does is it starts a Spring boot server. So this is what those 14 lines do. They have a main method and just say, hey, Spring, start. And it has an annotation which says enables Hiero, which with the Spring integration framework, what I created says, okay, let's create a connection to an Hiero network. How to do that? Let me create application.yaml file here. And so I'm not good in, yeah, I have it. Okay. So the good thing is, and you see it here, that I now have for Hiero a full integration into Spring config. So I can set up an account ID you to use for transaction, the operator account, mirror node endpoint to connect to, network name, like Hedera mainnet network name must be, oh, that is outdated. It can be even more than that. I need to update that documentation. I can define the consensus nodes manually if I run my own network. I can put in the private key and so on and so on. So I have this integration here that I'm as a Java enterprise developer can use the tools I'm familiar with. And then I use a lot of Spring stuff here, like I'm defining a REST endpoint that is directly at slash. And what I'm doing now here is I inject in this REST endpoint an account client. And an account client is a client to interact with an Hedera network and do everything that can be done by the account and token service. Like, for example, just do client.create account. Create account with a given hbar information. Get the current hbar balance of an account or delete an account. And for this endpoint, I call create account, I get the account. I can now even say like account, let's add the idea of it, account ID created. Okay. And if I now start that application, we do not have an Hedera private key. So it looks like my application properties are currently broken on that one. Give me a second. I move it to the other screen. Um, oh yeah. Um, oh, I can show something. So I can even show this is the configuration file for my Spring application. Here I use the Spring names and say, hey, take this one out of the system environment. And the problem I had when starting that application is I need to set the location, working directory. The working directory need to be Hiero Enterprise Spring Sample. Where am I'm at the totally wrong place. Yeah, that is a problem because he's not finding that env file. So we need to go to Spring minus Hedera. Yeah, I created this when it was Hedera. It's already Hiero now. Go into the sample, boom, and let's do one. And now I don't have luck with that one. What's the problem here? Let's see if I can start the other one, the micro profile sample. Because it does the same, but not using Spring and using micro profile instead. Injecting an account client and all that. Okay, I will do something else. I will open on my desktop the Spring Hiero sample because I know that this is working in this window. And oh no, yeah, that is the sample we've already seen, which has this button like create token, remove token, and so on. And here we now even inject more. Now we inject an NFT client. And with an NFT client, let's create a REST endpoint here. So let's say we have a REST endpoint, and that REST endpoint is a REST controller that is at /API. And here we have a method public string get balance. And shouldn't return 100 because we have a private final account client that is automatically injected in this class. And when we call get balance, we do account client get operator account balance to string. So how much hbar does the operator has? Yeah, that might throw an exception. I don't care. And that is a get mapping for /balance. So let's start the application. And let's open a browser and go to localhost 8080 rp/balance. And we have an error. Why do we have an error? That looks good. That looks good. Ah, yeah, that's a problem. Yeah, okay. So it's not, this one is just a name. So here we need to do slash API slash balance. Okay, and now we start it again. Stop and rerun. And now we see how much balance the account that I have defined here as an operator ID has. So now we can do more stuff. Because I have all the wrappers created here, I could do an NFT repository, which is an NFT repository, and that one I can use to search for NFTs. So what we could do here is public string get NFTs. Okay, and now we can do NFT repository, find by owner. We need now have the owner. For that, I need to inject the Hiero context. And in the Hiero context, I have the operator account ID. Again, that was an exception. And this find by owner now returns a page. Because in theory, somebody could own 1 billion NFTs. And we don't want with one request to get 1 billion NFTs. So what we have here is a pagination where we always can say like has next, and if it has next, and we get the next page. And each page has a list then of NFTs, which by default is, I think, like 20 NFTs per page. So let's assume it only has one and has never more than one page. So we can return that here as a page and do get mapping again, API NFTs. Okay, so let's restart. Copy that one, and we have an API NFTs, and we have an error. Oh yeah, sure. We need to inject all that. So we need an NFT. So what I'm doing here is that is something that Spring does. By adding them to the constructor, they will be automatically filled, which is great to have like enterprise framework functionality like that. And you can have the same in JavaScript or in other languages with frameworks like Angular, React, whatever. Okay, looks like we do not have any tokens. So let's create another endpoint that we call like create some NFTs. And here the NFT repository can only be used to search for NFTs. So what we need is we need the NFT client. And again, now edit here. Say this dot NFT client is NFT client. And what we do here is we do NFT client dot create NFT type. We need a name and a symbol, Hiero NFT HT. Okay, then we have the NFT type. And let's say the name is UUID dot random UUID to string 12. Every time we call it a totally different name. And then we do NFT client mind NFT for that type with, this is now metadata. And with that, we get back the serial that we have seen. So this has now minted for this NFT type. a new NFT instance, and we have different mind functions where we can directly define who should own that NFT and so on. So with this easy function, it just belongs to the operator. So what we now do is we do int n is equals mass. No, we do a mass dot random, but this is double. So we need to do like new random from system.current millis to have it random. And we do a next int something between 0 and 10. And then we do for this, we just mine an NFT. Okay. And then we return created X NFTs. Okay. Which is API. And we call it API mined. Oh, let's restart the server. So API mined. This now takes a moment because it's against testnet and it's not calling run transaction for all of them. It just creates a random number. It created fields. I recalled it, so we create a new NFT type and create 3 of those for the user. I assume if we now check the balance, we will see the balance is down because we called several contracts. And if we call now this, we see that we own of the token ID, which has the 62 at the end. One with series 3, one with 2, one with 1, and for another one, which has 61 at the end, we own the one with 4, with 3, with 2, with 1, which makes sense because we've seen one time create 4 NFTs, one time create 3 NFTs. So what we created now in, I don't know, 20 minutes or something like that, I assume it was even less, was a full application that has a REST endpoint that is using Java Spring to use services that easily connect to an Hiero network. And at the end, while this creates code that is super easy to read, right? If I go into the NFT client and go into the implementation of that and find the create NFT type and go into that and go into that and go into that implementation and go deeper and deeper and deeper, we will end at a point where the SDK as we know it is used to create a token create transaction, fill that with a lot of stuff. And this is now the magic that we got from Spring and things like that, that we just do mine NFT, NFT type, some random data here, and we good. And do not need to go that deep and do this and call the execute and things like that. This is all done for us, wrapped for us. We just inject the client or repository of the type we need, create a REST endpoint or put it in a view or whatever, and just call those functions to get the results. And that is the idea how you now can use any Hiero-based network and easily integrate that into enterprise software, into software that enterprise developers are familiar with, are using each and every day. So I think that is really now more or less the end of our session today. I mean, we are already, and there are even still more, way more than 10 people here. So there were way more at the beginning, but I talked now over 3 hours, mostly 3.5 of hour, and there are still so many people here. So thank you for that, for staying here with me and not letting me, talk all the time without having somebody who's listening. So thank you
Outstanding,
so much for
outstanding
that.
job, Hendrik. Just
Um,
So much information. This was great. I would like to open it up to everybody who's still on the call. Do you have a question for Hendrik? Either raise your hand or you can put it in chat and we'll see if we can address it. And as I say that, somebody had to leave. Oops. Um,
oh, I
well, how about
have
go ahead,
one thing
Hendrik.
I want to show. So for everybody who liked what you see and would like to contribute, right? Maybe some last words on that. So the best place today to start contribute is the Python SDK. Few other SDKs will follow. But why is the Python SDK the best place to contribute? Because for the Python SDK, we spent really some time to create issues that are very well documented, that provides a lot of help, like how to contribute, what to do, a lot of links with examples, and so on and so on. It uses this solo action, so whatever you do is automatically tested. Um, we have easy issues here, and that is really awesome. Um, if you want to contribute in that, we have a full webinar for that repository showing how to contribute. It's linked, I mentioned, I don't know, like 2 hours ago, this awesome contributions repository that contains contributions from the community, which is YouTube videos or articles and so on. And currently the last point here is a YouTube playlist for the Hiero Python SDK, which goes, I have no clue, like 2 hours or something like that, and containing a step-by-step guideline how to contribute to that SDK. So that is really, from my point of view, an excellent start, not only to contribute to Hiero, but to contribute to open source. And I think that's a good point to end with. So as John already said, if you have any questions, now is the best place to ask them. Otherwise, I'd be happy to answer your questions later on Discord, on GitHub discussions. You can connect with me on LinkedIn if you want to. I'm happy to answer questions there too. Yeah,
Can we
can
save the
you
URL of this meeting to
absolutely, yeah, yeah. So the recording of this meeting will be stored in the Asam contributions. I don't have a YouTube link before the meeting started. So that's why it's not here. Oh, that's a good point, right? So whoever is watching this on YouTube or is just here and has the YouTube link, a very good first contribution to Hiero would like to just add a new line to this document and link to the recording of the session. I'm happy to tomorrow morning when I wake up directly approve that contribution. So yeah.
Yeah, and so a couple of bits of housekeeping. So this has been live streamed to YouTube. It is up on YouTube right now. I'm going to go in there and put in links from this session. I'm going to check with Hendrik after this to make sure I've got all the correct links, but we're going to get the links into the YouTube description. It's those links as well will also be in the wiki page for this workshop, which is up on the Linux Foundation Decentralized Trust wiki. This video will be added. We'll get it onto this Hiero Awesome Contributions, but it's also going to be added to the Hiero playlist at LFGT. And I'll get you the link, Hendrik, if there are other playlists you want to add it to. And by all means, please join our Discord if you'd like to have more conversations with the Hiero team as Hiero evolves. Open source only works if people are using it, if people are modifying it, if people are contributing back. and any of those is acceptable. And even just checking out a workshop like this, you don't have to contribute. We love having you in our community. And we can't thank everyone enough for joining us today, especially those who came live, but also folks who if you are also folks who are watching this recording later. Sophie just posted, if you like the YouTube stream video, will be added to your liked list. And thank you for that, Sophie. That's awesome. And thank you for posting some of the links. Um, Hendrik, I'm going to give you the last word before I end the call.
I'm happy to go to bed in half an hour. It's quite late here, and it was, I mean, having so many people here in this meeting really gave me the power to talk like 3.5 hours, and I'm really happy to have you here, happy to continue those discussions with you. So yeah,
Above and
please
beyond,
think if you have
Hendrik.
any questions or if you need help, absolutely. Ping me if you need help.
Thank you so much, Hendrik. Thank you so much, everyone who joined us. I'm going to end the recording in the stream. And thank you all. Have a great day, everybody.